Okay, good morning, everyone. As introduced earlier, my name is Susanna Kakoro. I am a student from the University of Namibia, and today I will be presenting to you an investigation on the occurrence of groundwater in typical Kalahari sand aquifers in the Kavango West region, Namibia. This study was done under the supervision of Dr. Innocent Mchingami and Dr. Josephina Hamtok. So this is the outline of my study, but for the sake of time, I'll just jump straight into the introduction. Okay, groundwater is often underestimated in areas that rely primarily on surface water, as stated by David. And the Kavango West region, located in northeastern Namibia and bordered to the north by the perennial Kavango River, is home to approximately 120,000 people, according to a population census that was done in 2023. Access to the river is unequal, as communities that reside close to its banks rely primarily on surface water, whereas communities that reside inland or further away from the river rely primarily on groundwater. The region is also prone to frequent droughts, which has led to the drilling of drought relief boreholes across the region. Regardless of the increasing dependence on groundwater in the region, there is limited research on groundwater systems that have been done, and this lack of knowledge hinders effective groundwater evaluation and sustainable management in the area. So figure 1 is just a location of my study area that was modified after Haindongo. Okay, so my study focused on five selected sites across the region, and it aimed to improve the understanding of groundwater occurrence and supporting sustainable water supply development. Objectives included an integration of hydrogeological and geophysical methods to investigate structural frameworks and groundwater controlling mechanisms across the Kalahari Sand Aquifer to determine how subsurface structures influence groundwater occurrence and movement. We also assessed the quality of groundwater in the Kavango West region with reference to Namibian drinking water standards and World Health Organization guideline values. Sorry. So this is just a quick description of the study area. The Kavango West region is a semi-arid region. Just to emphasize again, it is bordered to the north by the perennial Kavango River, and it receives round about 62.53 millimeters of rainfall per annum, and it is characterized by two aquifer systems, the primary porous shallow Kalahari, the primary porous aquifer, as well as the secondary fractured aquifer. So figure 2A shows the major aquifer types in the study area that are of porous aquifers with moderate potential that yield 3 to 15 cubic meters of water per hour. And it's also important to note that the groundwater moves towards the Kavango towards the Kavango River in the northern direction. Okay, so figure B is just a conceptual vertical hydrogeology of the study area from literature, which just highlights the aquifers more, and it is seen that the Kalahari sand aquifers are comprised of sands as well as sandstones and gravels and conglomerates, and the basement pre-Kalahari bedrock, which are primarily of the Karoo and Damara, comprise of basalts, sandstones, schists, and minor granites. Okay, so figure C just shows how my sampling points were distributed across the Kalahari and Namib sands in the study area. So this is just an overview of the materials and methods. The study combined field measurements, as well as groundwater sampling and lab analysis with geophysical data processing. So we acquired borehole coordinates and borehole completion reports from the Ministry of Agriculture, Water and Land Reform, and also magnetic data from the Ministry of Mines and Energy. And then field work consisted of on-site groundwater parameter measurements such as electric conductivity and groundwater samplings of major ions and stable isotopes. Okay. Laboratory analysis were also done, and then data processing was done on the magnetic data that was acquired from the Ministry of Mines and Energy, where we did magnetic filtering using Oasis montage, and resistivity profiles that were generated from the PQWT system were plotted against lithological logs. So a combination of this data enabled me to analyze the water quality and geophysical processing within my study. Okay, just to jump into my hydrochemical results, Figure 4A shows the EC levels from the collected samples, and it can clearly be seen that they all fall within the suitable World Health Organization standards, which shows that these samples are of good quality, like are acceptable for drinking. And then figure B is just a paper diagram that shows that both my groundwater and surface water samples are of calcium magnesium bicarbonate types, water types, which is due to interaction with calcium carbonate minerals in the sediments, in a sense. This is also supported by the Gibbs plot, which shows that the dominant process controlling the water chemistry was rock-water interaction. And then the isotope values shows depleting values, which shows that the samples were of meteoric origin, and there was no evaporation enrichment, so the aquifers were directly recharged by rainfall. Okay, so moving on to the geophysical results, based on the aeromagnetic surveys that were done and also the filtering of our data that we acquired from the Ministry of Mines and Energy, we generated the reduced pole maps, the first vertical derivative maps, and the tilt derivative maps, as well as the analytical signal maps, which were digitized using QGIS. And yeah, it's quite visible, but we were able to digitize some faults, some deep-seated faults that stretched towards the river and inland as well. Ground telluric survey results. Okay, so I did quite a number of them. I did 5, but for time's sake, I'm just going to focus on these 2 that were quite interesting to me. So, so the ones from the Chara West borehole and the ones from the Nunu borehole showed that water strikes were in contact lithologies between the topsoil and the sand and sandstone lithologies as seen. So yeah, because 7 just shows the magnetic survey results, 2D profiles generated from the PQWT device alongside the geological log results compared to the electrical potential difference curve plot. Okay, just to conclude, overall groundwater in the study area is safe and sustainable and is categorized as drinkable according to Namibian drinking water standards, and moderately resistive sandy and weathered sandstone lithologies, as well as deep-seated faults in the basement rock act as key pathways and storage zones controlling groundwater occurrence, which is the movement and accumulation in the study area. Aeromagnetic surveys also support the presence of 2 aquifer systems in the study area. My recommendations are to expand borehole coverage across the Kavango West region to improve the spatial understanding of groundwater occurrence in the aquifer. As you could see, I only used 5 sample sites. And yeah, so the other recommendation is to conduct similar integrated studies in the Kavango East region to enable regional comparison and support broader groundwater resource assessment, and also lastly to increase ground-based geophysical surveys, particularly electrical resistivity, tomography, transient electromagnetic methods to validate airborne data and enhance subsurface resolution. Thank you.